The boundaries between man and machine are melting away, just as philosopher Devija Mehta predicted. Sounds futuristic? Well, the future is now. In a jaw-dropping moment, Nolan Arbaugh, after 8 years of paralysis, played chess with his mind. No hands, no moves, just pure thought. Thanks to a breakthrough brain implant from Elon Musk, Neuralink, he unlocked abilities he never thought possible. Want to know more? Stick around to discover how this tech is reshaping what it means to be human. The richest person on the planet is pushing humanity closer to a commercial brain interface. That's right, Elon Musk has officially announced that Neuralink, his futuristic company, has successfully implanted its brain-computer interface into a human for the first time. And according to Musk, the recipient is recovering well, with early results showing promising neuron spike detection. Basically, they're tracking the brain's electrical activity. Each of these Neuralink devices is packed with a chip and over 1,000 super-thin, flexible electrode arrays that a surgical robot threads directly into the cerebral cortex. These electrodes, they're designed to capture thoughts related to motion. Musk's endgame is Wild, an app that turns your thoughts into action, whether that's moving a cursor or typing out text. As Musk puts it, imagine Stephen Hawking communicating faster than a speed typist or auctioneer. That's the goal. And this revolutionary tech even has a name: telepathy. Neuralink's device is about the size of a coin, implanted into the skull, and is equipped with ultra-thin wires that can read brain activity and send wireless signals to a receiving unit. So far, they've tested it on pigs and claim that monkeys have even managed to play a basic version of Pong using just their mind. And now the first human has received their implant, though details are still pretty vague. All we know is that according to Musk, the patient is recovering well, and there's been some promising neuron spike detection, which essentially means the brain signals are being read. While it all feels very futuristic, Neuralink is actually playing a bit of catch-up. One of its main competitors, a startup called Synchron, backed by some serious names like Bill Gates and Jeff Bezos, has already implanted its stent-like device into 10 patients. Back in 2021, a 62-year-old Australian named Philip O'Keefe, who has motor neuron disease, became the first person to compose a tweet using just his thoughts to move a cursor. Pretty mind-blowing stuff, but for Musk, tackling brain and spinal injuries is just the beginning for Neuralink. His long-term vision? A full-on human-AI symbiosis, which he believes is species-level important. The real challenge ahead will be developing a system that can interpret brain signals with a much higher degree of accuracy. If Neuralink or any company can crack that code, we could see humans communicating with computers and devices in ways that are almost unimaginable today. This groundbreaking moment comes after the U.S. Food and Drug Administration gave Neuralink the green light for human trials in May 2023. By September, the company had already opened enrollment for people with quadriplegia in its first study. When Musk first launched Neuralink in 2016, his grand vision was to merge human brains with AI. While we're not quite there yet, the immediate goal is to create neural keyboards and devices that give people with paralysis power to control computers. But it hasn't all been smooth sailing. Along the way, Neuralink has faced federal investigations over issues like dead test animals and the mishandling of hazardous material. When Musk first introduced Neuralink in 2016, his vision was something straight out of science fiction, fusing human brains with artificial intelligence. While that ambitious dream is still on the horizon, the company's current focus is on developing neural keyboard and other devices to help people with paralysis control computers with their thought. But Neuralink's rapid progress hasn't been without controversy. Federal investigations have been launched into their handling of dead study animals and the transport of hazardous material, casting a shadow over their otherwise groundbreaking advances. Elon Musk is known for making bold claims with, well, not always a ton of specifics to back them up. Ryan Merkley, Director of Research Advocacy at the Physicians Committee for Responsible Medicine, points out that this latest Neuralink announcement is a prime example. We still don't know who received the implant or what their medical condition is, which, as Merkley notes, makes it tricky to define what success really means. After all, depending on the patient's disorder, the outcome could vary wild. But could Neuralink really achieve those wild futuristic goals Musk keeps hinting at? That's still the million-dollar question. Brain-computer interface, or BCI technologies like Neuralink are more than just a technological breakthrough. They represent a shift in how we think about the connection between the human brain and machine. They challenge our deepest intuitions about identity, selfhood, and even personal responsibility. In the short term, this kind of tech holds enormous promise for people like Nolan Arbaugh, but it doesn't stop there. Neuralink's long-term vision? Offering these implants to general public to boost and enhance their natural abilities. But here's the big question. If a machine starts doing things that were once purely the domain of our brain, does it become an extension of our mind, or is it something entirely separate? This idea taps into debates that have been going on for decades. Philosophers have long asked where the mind ends and the outside world begin. On the surface, it seems seems like a no-brainer. Our mind is inside of our heads, right? But some thinkers argue it's not that simple. Back in 1998, philosophers David Chalmers and Andy Clark introduced the extended mind hypothesis. Their theory suggested that technology could actually become part of who we are. They called it active externalism, a concept that claims we can outsource parts of our thinking to external tools, making them extensions of our mind. And while this theory predated smartphones, it pretty much predicted how we now rely on our devices for everything, from navigating to remembering important info. So, where does this leave us philosophically, now that brain-computer interfaces are no longer just a theory, but a reality? Arbaugh's implant now part of his mind, intertwined with his intentions, or is it something separate? Raising tricky questions about whether he truly owns his. To dive deeper, let's break down a key distinction: happenings versus doing. Happenings are everything going on inside our head, our thoughts, beliefs, desires, imaginations, and intention. Doings, on the other hand, are those mental processes put into action, like the way your fingers are moving as you scroll down this article. For most of us, there's no gap between happenings and doing. Take, for example, a woman named Sarah, just your everyday person, no brain implant. If Sarah is playing chess and decides to move her pawn to d3, she thinks about it and then moves her hand to make the play. In her case, the thought, happening, and the action, doing, are seamlessly connected, making the action completely her. But for someone like Arbaugh, things get a bit more complicated. He has to imagine his move, and then it's the implant that translates that intention into an actual action in the outside world. Suddenly, there's a separation between his happenings and his doings. So, if his mind creates the intention, but the implant carries it out, is it still fully his action? This question opens up a philosophical can of worms about the nature of control, ownership, and personal responsibility in this brave new world of brain-machine integration. While the idea of Neuralink becoming a go-to consumer product is super exciting, there are some serious practical hurdles to jump over. For starters, every brain is unique. As one expert pointed out, you can't just slap the same chip into everyone's skull and expect it to work the same way. It's going to require a meticulous, personalized approach to each individual's brain structure. Then there's the question of technology lifespan. With how quickly tech evolves, would users need to swap out their chips every few years? Imagine having a clunky old Nokia stuck to your head. It was cool back in the day, but now it's pretty much obsolete. That could be a real concern for folks who want to stay up to date with the latest advancement. Balancing innovation with practicality will be a big challenge for Neuralink if it hopes to make a splash in the mainstream market. While we might be dreaming of brain-machine interfaces revolutionizing our lives, experts agree that we're still decades away from seeing this tech in your local brain surgeon's office. Elon Musk has a point when he emphasizes that the ultimate goal isn't just about speeding up your takeaway order. It's about safeguarding humanity from the potential risks of AI, which he's called an existential threat. By merging our brains with computers, we might just ensure we're not left in the dust as technology races ahead. As Musk puts it, with high bandwidth brain-machine interfaces, we can truly go along for the ride. If you're as intrigued by the future of AI and brain tech as we are, hit that like button. And don't forget to subscribe and tap that bell so you're always in the know about the latest advancements. What do you think about the future of brain-machine interfaces? Drop your thoughts in the comments below. We'd love to hear from you.